This video is for the solving equations from quadratic functions. Ooh, I'm sorry, that should say exponential functions. I apologize for that. Exponential functions. All right. A coral reef has an area of approximately 10 acres and is decreasing in size at a rate of about 10% each year. All right, we are going to identify the independent and dependent variables represented in the question and the function. So the independent variable is the t, which is the time in years. The dependent variable is a of t, which is the area of the coral reef. All right, we're going to write an exponential function for the situation. So we're going to have a of t equals, all right, our starting amount, our y-intercept is this 10, and we're decreasing at 10% a year. So 10% as a decimal is 0.1. So since we're decreasing, we're going to subtract that value from 1 and get 0.9. So that is our b value. And then to the t. We're going to determine the solution to the questions tabularly and graphically. So let's do a graph first. We're going to use the function to create a graph for y equals a of t. So we're going to graph this function. And we're going to determine how long it will take the coral reef to have an area of 7.5 acres. So what I'm actually going to do first, I'm actually going to fill in my table just so I've got some values to plot. So our function was 10 times 0.9, and we're going to raise it here in this, well, maybe to the x power. And then I'm going to pull up the table here. All right, so just to get some basic values to start with, I'm going to do, let's do 1 through 5. So 1, 2, 3, 4, and 5. So 9, 8.1, 7.29, 6.561, and 5.9049. Okay, so now I've got something I can kind of graph here a little bit. All right, so we know our y-intercept is 10. We're going to have a point there. 1 is going to be a 9. 2 is a little bit greater than 8. 3, 729. 4 is almost 6.5. And then 5 is 5.9. So again, kind of have to eyeball it a little bit. And so this graph is going to do something. It's going to keep kind of going down this way. It's actually going to be a little bit steeper than that, but that'll do it for now. All right, so we're looking for when it will take the coral reef to have an area of 7.5 acres. So on our graph, x is the time, and this is the acres. So 7.5, about halfway, would be about here. So I can follow that till I hit my graph, and then I can follow that straight down. And so I land somewhere in between 2 and 3. My line's a little bit off here. I didn't do a very good job drawing a straight line. But somewhere in between 2 and 3. And so we're going to say about maybe 2.8 years. Now, if we use a graphing calculator, so what we can do, if we use a graphing calculator here, I'm looking for where y is 7.5, and so I can kind of see here in between 2 and 3, and there's some different tools I can use as well to help me find that value. But if you use a graphing calculator, you get approximately, I think it's like 2.73. And so what you can do, let me show you in here because I believe, yeah, that value's a little bit different. I can take this table. Well, hang on. Control T. Let's pull that table up again. Control T. And do menu, table, and then I can edit these table settings. And if you change this to 100th, it gets really accurate. You can also search on this table, back in these table settings. So we know it's going to be in between 2 and 3. So I can start at 2. From the graph, we estimated 2.8, so that's kind of where I can start. And you can go through here, and so there's 7.5. That's about as close as we get at about 2.73. Gets you just a little bit more accurate of an answer. Okay. So let me close this out because we're going to need it again. So now we're going to use the function. We've already created the table, and now we're looking for when we're going to have an area of 6 acres. So looking at our table, we can see that it's going to be somewhere between 4 and 5. So the function value of 6 occurs between 4 and 5 years. Change the interval of the input column to 0.1 to better approximate the solution. So I could go here and start at 4.5. And again, you could take these values and you could plug them in for t. We're just going to use the table again here. And I'm going to go to menu and edit the table settings. I'm going to start at 4.5, and I want this in intervals of 1/10. And I can get a little bit more accurate values. And so you can see how long these numbers are. I'm going to go with what the table rounds them off to. So 6.22431, 6.15908, 6.09452, 6.03065, 5.96744. And so now looking at it, I've narrowed it down further. It's going to be at 6 acres, somewhere between 4.8 and 4.9 years. And so I can narrow it down even further. I can change the table now to hundredths. Because we know it's going to be somewhere in there. And so back to my table. I'm going to start now at 4.81. I'm going to change the step to 100th. And then I get some new values that I can use to estimate. 6.01795, 6.01162, 6.00529, 5.99896, 99265, and really once I get to the point that I need, I don't have to go any further because we can see the changeover right here. It's going to happen between 4.84 and 4.85. So in approximately I'm going to go with this number here, and approximately 4.85 years. And again, I could go even deeper than that. I could go back here to the table. If I want to get really accurate, 4.85, I could take it down even further and see how close I get. 4.849, and you're never going to get exactly it, but you can get pretty close.